This one here, we're going to give I gave you the description and you're going to go to the equation. So we have, if I want a whole, and again, this is not, you don't have to go too complicated. This is not too bad. X equals 3. If I know it's a whole, then I put the same factor on the top and the bottom in the numerator and denominator. Numerator and denominator have to have the same factor. If it's x equals 3, you're solving it for 0, right? So you bring it over to the other side and you get x minus 3. Yes?
If there's a whole, it wouldn't be a function, right?
If there's a whole, you can, the question is, if there's a whole, it wouldn't be a function? No. There can be a whole in a function, right? There can be a whole, so if I gave you this with a hole in it, could be a function? Yes. So it can be a whole, a function can have a hole in it, yes. Yes, question?
Would you have to have something else in the top then?
No. So that's why, don't go too fancy on it. If I was to cancel that out, that ends up canceling to be 1, which means, what do I have? It's a horizontal line, and I poke a hole at 3, boom, done. So you can put more stuff, just be careful. If you add too much, sometimes you contradict yourself, and then you go, oh no, now I created something wrong or too much. So you can put bracket and put something on the top. You can put an extra x, you can put another number. Just try not to do anything that's going to take away your whole. I think you couldn't do that, but yes. Yeah, but you can leave it like that as well. Okay, that's good. Next one, I want a whole. Okay, so, oh, also, it's an equation. Rational function, it has to be rational function, of course, but equation, so you have to have something on the left. It can be y equals or f of x equals, but you have to have something. An equation means this, right? So y equals, or you have to have f of x equals. You can't just have the left side. You're concentrating so much on this part, sometimes you forget to write this. Okay, so don't forget it's an equation. It should be automatic, y equals or f of x equals. And then, right, so to make sure you get that. And then make sure you try to center your equal sign now, because now you're in grade 12. I actually made grade 9s, I expect. Try to center your equal sign. You're writing the equation. Try to write it neatly. It doesn't have to be neat. It's more about accuracy, right? I don't want the f of x here on the top or in the bottom. Try to put it in the center. Okay, you're setting up the equation, so should be okay. Whole at x equals 1, so I'm going to go x minus 1. X minus 1, right? Opposite sign when you bring it back. Vertical asymptote at x equals 4. Oh, and I've also had the question, do I need extra brackets? Please don't put extra brackets, right? You know, and again, in grade 12, we clean up. So I don't need extra brackets on this. Don't put extra brackets on it. Just clean it up, and that's all I need. Okay? So don't leave your answer. If the question was asked, can I just leave everything in brackets? No, like that's not neat. So here, I have the whole here. If I'm going to put the vertical asymptote, now I need a bracket. So if I put a vertical asymptote, now I need a bracket, and I want the vertical asymptote at x minus 4. Before or after, it doesn't matter, but somewhere on there. Anything else? Nothing. You can put more, but don't contradict yourself. Like, don't put another x minus 4 on the top, because now you're contradicting yourself, and you're all good. Okay, but I can leave it like that. That's fine. Okay, next one. All right, this is new. Oblique asymptotes. We already know it's rational, so I set that up. Oblique asymptote. If it's oblique, I know a couple things. I know that the degree is higher in the numerator, right, by 1. Right? So again, just a note to myself. I want the degree in the numerator to be higher by 1. So again, this is just a quick note to myself. Vertical asymptote, I want no vertical asymptote. It still has to be a rational function. So rational function means there has to be something, an x in the denominator. Some people go, well, I'm not going to put an x in the denominator. I'm just going to put a number. Ha, I tricked you. And you give me a number here. And I go, no, that's not a rational function. Is this a rational function? No. If there's no x in the denominator, people go, yeah, because you can't solve, look at that. And I go, that's not a rational function. That's a line. That's 3/2 slope. That's a slope. It's a line. It's a linear. It's not rational. You need an x in the denominator in order for it to be a rational function. If not, if there's no x in the denominator, it's a line. Or this, it's a parabola. So there has to be x in the denominator. Does that make sense? To make it a rational function? So you have to have an x in the denominator. But how do I get it? So I have an x in the denominator, but I can't solve for a number. When did we see that? Where I said we tried to find the vertical asymptote, but when we set it equal to 0, I got no solution.
When it was like root of negative something.
Yes, and how do I get a root of a negative something? I go x squared, maybe? And then, can I go x squared minus 1? That will give me an answer. So it was x squared plus, yes. So what the trick with this was, is that we needed this to be even, an even exponent. You can do 4 even. You can do 4, 6, 2, anything even with a plus. Then we could not answer it. So when we do that, then we get no solution when we try to solve it, right? Because then, for example, so if I do, and you can do any number. You can do any number at all, so I'll just put 1. Right? So x plus 1, I'll do that in blue here, so 1. So for example, if I did x squared plus 1 equals 0, I get x squared equal negative 1, and look, I cannot square root. No solution. Right? So no solution for that. So that was why. Yes?
Wouldn't you not be able to do synthetic for this thing?
You don't have to do synthetic in order to find an oblique asymptote. So the question was, but what if I can't? You can find an oblique asymptote for anything. So if I had 3x cubed, so equals, plus 5x minus 2, and I had this on the bottom, that is 1 degree higher than this. There will be an oblique asymptote. I can't do synthetic. You would have to do polynomial.
Yeah, okay.
Yeah, so you'd have to do polynomial. But that would still get me a y equals mx plus b at the end, yes. So that would give me an oblique asymptote, but you could not use synthetic. You'd have to use polynomial, right? So that is all the rule is. Yes, question?
What if you accidentally made it so that it divides with no remainder? And would you give me no oblique asymptote?
Yes. Yeah. Okay, so the question was, can I just make it so it's a division but with no... Wait, sorry. You want a division with no remainder? Then it's a whole.
No, I'm saying, like, don't you avoid there being no remainder to make sure that there's a remainder?
Yes, yeah. But now you're overcomplicating it, right? So you're not going to accidentally choose up here so that you divide it with a no... Don't put x squared plus 1 up here is the answer, right? So just make sure x squared plus 1 doesn't appear up here. If you do,
No,
then
but
yes.
There can be even division that's not x squared plus 1.
Yeah.
Like 2x squared plus 2. That would have 0 remainder when you divided it.
But you'd be canceling it away. So just don't put the same factor on the top, okay? Now you're overthinking it. Just don't put the same factor on the top, and then it won't cancel away. Okay? So hang on. So let's just finish the question, because now you're overcomplicating it. You're thinking of multiple different scenario possibilities. All we want is not possible to solve here on the bottom, and then how do I get an oblique coming out of this here? What do I have to do to the top? So to get an oblique out of this, but that didn't divide out, what do I have to put on the top?
X cubed.
X cubed. So anything with x cubed. And yeah,
Let's say you did
but
x,
don't.
X cubed plus x.
How about
by
don't?
accident.
But just don't. This is why. So I'm saying don't add more stuff. That's why I said don't add more stuff, because then you're going to get something. So yeah, the question is, what if you put x cubed plus x here? Because then, yeah, it factors out and you're canceling. So now you've just taken away your oblique. So don't do that. Okay, so we're going to, don't put x cubed plus x so that you get the common factor. So we basically don't want this to factor out and cancel. Other than that, don't complicate it. So we just want this to be a degree higher and don't make it any fancier. So that's why I get people who put extra stuff and I'm like, now you've created a worse scenario. So just put that. We know it can't cancel out. We're good to go. Okay. Next one. Set that up. Vertical and horizontal. The vertical is usually easier to start with because we know it's x minus 5. So I put whatever I can think of first. The horizontal. So oblique was higher degree in the top by 1. Horizontal, so this part here, I need the degree to be same. Does that make sense? It's not the proper way of writing it, but I want the same degree on the top and the bottom. This is just my brain going, wait, what does that mean? If I say horizontal, I want the same degree on the top and the bottom. Does that make sense? Right? So just don't make it more complicated. I want the same degree. So on the top, so I have the vertical. On the top, I want the same degree as what I have on the bottom. the coefficients, so the coefficients to be canceling so that it becomes a negative 6. So if I have this on the top, what should I put? Negative 6x. And don't go fancy. Exactly. Don't add too much other stuff. I don't want too much else, because if you do too much, you might accidentally create a scenario where you're now contradicting yourself. Okay, so that means your coefficients would be negative 6x and x, and that gives us, right? So that gives us this with the 1, and that gives us that. So that's what you're looking for. And again, don't make anything more complicated, because yes, you can create scenarios where you're going to contradict, and now you've made it more complicated than it should be. Okay, last one is vertical asymptote anywhere horizontal at 2. So my vertical asymptote, so let's set this up. Okay, rational, so it's new, top and bottom should have x's. Vertical asymptote anywhere, so I know it'll be, I don't know, x something. Horizontal at 2. So in the top, I know it'll be a 2x to match it. So I get, sometimes when I get people who do this, they do that. And they said, you said not to do anything fancy. So I didn't. But what happens if you do something too simple and you stop too soon? I get this, I put this in because I've given this question before, and this is the answer I got. What did you do wrong? What do you think? Sorry, I didn't simplify it. I don't, kind of on the right track, but what else? What did I do wrong for the answer for this? Yeah.
The asymptote is x equals 2 instead of y equals 2.
X equals, for this one, x equals, oh, sorry, yes, sorry, this is a typo. Ha, thank you. And also I had a typo. I don't know why, but my old, I don't know how I printed that wrong. So look, my old one I had, my old notes, it was right, and somehow I edited it, and I edited it wrong. So thank you. That's a typo, and I should fix that later. So typo in the question, first of all. But also, what I asked this properly, there was a y equals 2, but also, thank you. So that's totally a typo on my part. So it should be y equals 2, exactly. But I got that as an answer, and I realized, oh, shoot, what did they do? Because I kept saying, don't go fancy, don't do anything too fancy. They stopped here. But what's wrong with that answer? Yeah.
You have to add
Wait,
like
back corner, sorry.
+1.
Why do I have to add +1?
Because otherwise it's just like a line at y equals 2. It's not like an asymptote.
Yeah, because it cancels. You created a hole. So that's the scenario. Because I keep saying, don't go fancy with these guys. Then people went, you said not to go fancy. But they stopped too soon. They said, asymptote, I put the x, I made them match, and I stopped. But look, you have a hole. So then you went too soon, and now you have a hole. So just put any number, anything you want, +1, plus a million, minus something, plus anything, or minus anything. So anything here. Anything else. Just don't stop. Because they went, Ms. N, you said stop. And I'm like, not too soon, though, because then it created a hole. And I went, I'm so sorry that you created a hole, because you stopped a bit too soon. Because after we did these, they went, oops. So make sure you double check, look at one more time, and go, did I create something I didn't mean to create? For instance, something that cancels. Right? So don't create something that cancels. That's what you guys were asking up here. Yeah, don't create something that cancels. Take a look one more time. Did I do something that I didn't want to do? So that people stopped too soon. Yeah. Yeah. Okay, so here, does that make sense? Don't stop too soon. After I did these, I realized, yep, you stopped. And yes, I have a typo. Thank you. Perfect. Good. Anything else?